Hello everyone, hope you're doing well. Today we're going to get started with our math lesson on equivalent fractions. Last math lesson we went into just fractions, just a quick overview on what they are, how they can be represented as well. Now today for equivalent fractions, let's take a look at today's anchor chart. It says equivalent fractions show the same amount, but they use different numerators and denominators. Remember, numerator is the part, the denominator is the whole. You can use pictures or models to find equivalent fractions. Now we have a model. We have a fraction 2/6. There's 2 of them out of 6 that are shaded orange. But as you can tell, we have the same rectangle, but it says 1/3. Now this is a different way to represent the same amount, but with a different numerator and denominator. As you can see, the same amount of space is being filled up. Now looking over here, we have 8 dots, but only 4 are filled. So we have 4/8. Now, how else can I represent this? So we have 8 dots again, but then a different way to represent this is 1/2 of these dots are colored green. But as you can see, the same number of dots are being colored, but they're just represented a different way. Now, you have pictures, you have models. Another way to show fractions is on a number line. You have 0 to 1. So this is 1/2. You have 1/2. So it says 2/2 makes 1/2. Now, if you divided this up in the purple, we have 4. If you divided this up into 4, so if I jump 4 times, I have 1/2. So as you can see, 1/2 is equivalent to 2/4. If I jump 2 times, I'm in the same distance, the same amount. Now, if I divide up my 1/2 into 8 pieces, okay? If I divide it into 8 pieces, then it will take me 1, 2, 3, 4 jumps. So that means 4/8 to be equal to that 1/2 to 4th. But as you can see, you can start seeing some patterns. 1 jump of 1/4 is equal to 2 jumps of 2/8. 3/4, that means 3 jumps is equal to 6 of the 8th. Okay, so you're going to be seeing different patterns like that when you get into the equivalent fractions. Now, literally what they're doing and you're explaining is, how else can I represent this? Now, we have 2/3. I have my bar or my model here. I have 2 parts, 3 equals 1/2. 2/3. So I have to figure out 2 other different ways that I could represent 2/3, but with a different numerator and a different denominator. So what I'm gonna do first is I'm gonna add my lines again. And if I go ahead and shade in the same amount of area, 1, 2, but it's still the same thing. But I say, wait a minute, all I have to do is divide it up in a different way. So if I add a line right in the middle, just like this, then my fraction changes, but it still represents 2/3. It's an equal fraction of 2/3. So in this case, I have 1, 2, 3, 4 shaded areas out of 6 in this case. So 2/3 is an equivalent fraction to 4/6. Okay. Now I'm thinking myself again. Let me try it again for the last one, but I have to think of another fraction or another way to divide it equally. okay? I can't end up with 6 or a little bit over here or divide up this to make it, no. I'm gonna do it once more again, the same way. I'm gonna make 2/3. I'm gonna shade in my area, just like this. But now I start really thinking about it. Okay, how else can I divide this up where it makes an equal amount of either the shapes or different partitions, okay? So I look at this and I say, okay, 3, 6. Let me go ahead and try to divide it into 9 different little squares. So what I'm gonna do to get an equal amount, I added 2 lines instead of 1. So right now my equivalent fraction would be, I have 1, 2, 3, 4, 5, 6 squares shaded in out of 9. So then I have my last equivalent fraction, 6 out of 9. So these are being represented with different numerator and denominator, okay? But how our anchor chart says, it's the same amount. It's just being represented differently. 2/3 is equal to 4/6. 4/6 is equal to 6/9, okay? That's a different way using the models. Now, when we're looking at a number line, okay, I have all 3 already set up. I have 0, 1/3, 2/3, 3 out of 3. Okay, that means 3 parts equals to 1 whole. I have the 6, 1, 6, 2, 6, 3, 6, 4, 6. And then I have the 1/9, 2/9. So my first one I'm gonna plot, I just wanna see if I plot each of them, will they end up in the same distance? So first one is 2/3. I have 1, 2. I'm gonna add my little jumps as well so you can see it. 1, 2. So there's my first jump. 1, 2, 2/3. Next one is 4/6. So now I'm gonna jump 4 times out of these 6. And just look at that. It is the same distance on that number line. Even if it was like if you were on the driving on a little car and someone asks, oh, how far are you? You're gonna say, oh, I'm 2/3 the way, or I am 4/6 out of the away. Okay. The last one we have is 6/9. Now I have to jump 6 times. These are smaller jumps, but it's the same distance. 2/3, 4/6, and 6/9. So as you can see, you can represent them using a model, using a picture, or you can represent it using a number line. But you have to remember that in that number line, equivalent fractions means equal value. That means they have the same value, okay? I can say 1/3 is equivalent to 3/9 because I can just kind of go down and see that. I can say 2/3 is the same as 6/9 as we saw in our example right now. And to wrap up on equivalent fractions, when we're looking at something that's like a circular or circle, we're gonna see something like this, okay? We're gonna see how 1/2 is equal to 2/4. 2 of these parts is equal to that 1/2. 2 of these parts, if you cut them up in half, then you have 4 out of 8 will be equal to that 1/2, okay? It's all about how you can divide it equally. When you get to bigger numbers, it's really hard to do that. When I was working on that 1/3, that one slice right here is equal to 2/6. When we have 4 out of 12, like I know when I got into my 12, I have to really count my little triangles all the way around, make sure there is 12. And I would look at this and say, 4 of these slices is equal to 2/6. 2/6 is equal to 1/3 as well. Okay, so going into third grade, they're going to be asking you how many of these is equal to 1/3. How many of these is equal to 1/3 as well. That's how we look at equivalent fractions in third grade. If it's looking into even numbers, okay, all you have to do with these is keep dividing that shape, but in equal parts, okay? If I divide up by half, that should be equal to that 2/4. If I divide it up into thirds, that means I should have 3 pieces on this side, 3 pieces on that side. That's going to be that 3 out of 6, okay? So there's different ways to divide that up to make it equal to another one. Now, if I divide up my half, just like that, and I add an X, this would be 1, 2, 3 out of 6 is equal to 4/8, 2/4, 1/2. So as you can see, there's different examples that you can use with when it comes to a circle. It's almost dividing up a slice of pizza, how many equal parts, so that each person can get an equal amount of slices. Okay, now in our class story for today, I'm gonna post this video, and then after this video, you're gonna turn or swipe the post photograph, and you're gonna see an assignment about equivalent fractions. Work that out on a notebook sheet of paper, number it down. I believe there's about 8 to 12 questions. Snap a picture today and send it. Look at the date for today. So if it's April 22nd, do those assignments for today. I know you already have one for reading, one for math, and every other day you have science and then social studies. Tomorrow is Alien Arena Live at 1 o'clock. Okay, it is for a grade, so once you see it's 12:55, I'm gonna go ahead and post up the Alien Arena battle. It's gonna be math first, so look for math battle.